And welcome to another video on additional mathematics. So this one is going to be talking about another aspects of function. We call it composite functions. So basically here today you are going to deal with how to form a composite functions, and you are going to solve problems involving composite functions. So basically here, before you start to do the rest of the page, let's begin with doing the starter yourself. So here the question is, write down the letter of each graph which does not represent a function. And now I will ask you to pause the video and try to solve the question on the starter part. Pause the video now. Alright, so the answer for the starter about which graph does not represent functions, okay, are A and E because they fails the vertical line test. Now moving on. Okay, now this is what we call a composite function. So if you try to understand from the diagram itself, so here basically the first thing that you see is the output, the input x, and then you apply the function g, so it will produce the output g of x. And then with the gx itself, so try to imagine that it is going to be the input for f. So here what you will have as the output is going to be f gx. So here basically the gx is sort of like substituted into f to make f gx. So for example, so let's use the expression. Here you have the function 2x plus 5. So it says that here it is a combination of the two functions g and f. So where gx is 2x and fx is x plus 5, which results in a composite function f gx. So function g acts on x first and then f acts on the result. So here what can I do as a demonstration for the topic is that, so you will start with which one is the main or the most outside function. So here the most outside function is fx. So here let's say fx is x plus 5, and then the gx is 2x itself. Now f gx means that you will make gx as the input for f, as I explained just now. So which means fx, okay, is x plus 5. Okay, right? So here the gx will be substituted into x, so which means f gx is actually f 2x, right? So f 2x, so which means the x will be replaced by 2x, hence the result 2x plus 5. Alright, x plus 5 over here. Okay, so that's how you get 2x plus 5 as the f gx. Okay, right, now one of the example here. Okay, let's move to example number 1. The function f is defined by fx equals to x minus 2 in the square brackets minus 3 for the domain x is more than negative 2, and the function gx is defined by g of x 2x plus 6 over x minus 2 for x is more than 2. The question is asking you to find fg of 7. Alright, so here, like I told you just now, if you identify which one is the most outside and which one is the most inside, then you will start with the most outside, which is gx. So gx over here is we're going to put in G7 first. Okay, we're going to find the G7 first. So G7 is here, 2x plus 6 over x minus 2. So 2 times 7 first, plus 6, everything over x minus 2, which is 7 minus 2. It's the continuation of the working. So for this one, you are going to have 14 plus 6 is 20 over 7 minus 2 is 5. That will give you a 4. So which means G of 7 is 4. Now here, okay, let's write down fx first. Okay, which is the most outside function on the left side. So x minus 2 square minus 3. But then f gx, okay, which is your your fg7, which is your question. That means it's going to be f4, because the result for g7 is 4. So here you are actually looking for f of 4. So f of 4 means, if you go back to your function with fx, fg7 is f4. So which means you are going to substitute x as 4. So the result is going to be x minus 2 becomes 4 minus 2 square minus 3. So this is fg7. So which will give you the result of 4 minus 2 square is 4. 4 minus 3 is going to be 1. Alright, so let's move on to the next example. In example number 2, you have two functions, which is fx and also g of x. So fx is 2x minus 1 for x is a real number, and g of x is x squared minus 5 for x is a real number. So the question is to find three types of composite function: g of x, g of fx, and then f, sort of like a power 2, but over here, okay, in the function notation, f of 2x means f of x. So you are going to apply the function f twice, as written in the notes, side notes. Okay, so please remember, this is not multiplication of f with f. It is just f of x. Okay, so let's begin with the first part, which is f gx. Right, so now f gx, okay, let's write down the most the right hand, the second function on the right, which is gx. So gx over here is x squared minus 5. And let's write down the most right side, which is fx, the left side, sorry. fx is 2x minus 1. Now, if you look at it carefully, for the question that you are given, you are looking for fg of x. So fg of x is f with the input of gx. So f gx is actually f of x squared plus 5, right? So which means the x squared plus 5 is going to be replacing the x in f. So fgx means 2x minus 1 will become 2 bracket x squared plus 5 minus 1. So you can leave your answer like this, or if you try to simplify this, you may do so by expanding and simplifying the terms. So you will have 2x squared plus 10 minus 1. So therefore, your f gx is 2x squared plus 9. Right, so that's for part A. And let's move on to part B. So part B is asking you g of x. So here, what I usually do is to write down the right part of the composite function, which is fx. So fx is going to be the one that is going to be substituted into g. So fx is 2x minus 1. and then write down gx. So gx is x squared minus plus 5. So g fx means that the input for g is going to be the expression 2x minus 1. So here you are going to change the x in the g of x. So which means the x will be replaced by 2x minus 1. So here g fx means x squared is 2x minus 1 to the power of 2 plus 5. Now you can leave your answer like this. This is already a complete function. But then if you decide to expand this, you are also able to do so. Right? But then in this case, I'll just leave the answer like this. Okay, now for the last part, part C, it's going to be f fx. Okay, so let's write down back. F and then 2x means f, and then it has input of fx. Okay, so fx itself above is defined as 2x minus 1. So which means you are going to have a function of f with an input of 2x minus 1. But then it itself, fx itself is 2x minus 1. So let's write down 2x minus 1 first. Okay, for the understanding part. But then the x itself is replaced with fx, which is 2x minus 1. So which means you are going to write down 2 bracket 2x minus 1 and then minus 1. So you are going to simplify this. So it will become 4x minus 2 minus 1. So therefore f over 2x, okay, means the composite function of ff. So this is 4x minus 3 as the final answer for all of the composite function. Okay, so this is about producing or forming composite function. Now as for the example number 3, this is quite a recent topic in which you are going to find the domain and the range of a composite function. So here let's see what we are dealing with first. So fx is x squared plus 4, for x is a real number, and the domain for that particular function f is x is less than 0. Alright, so for the second one, which is gx is equals to 8 minus x over 2. For x is a real number and the domain for gx is x is more than 4. So let's begin with finding the domain first. Alright, so for the domain of the function f gx, let's look at it, break it down into what are the functions involved here. So here, as we are referring to this diagram, right? So here we have to look at it one by one first. So here x, okay, as the input of gx, right? So let's have a look at the condition of gx. So gx over here has a domain of x is more than 4, right? Nothing too much a problem about that one. But then when you go into fgx, okay, fgx is essentially a function of f. So which means the domain of this function must follow the domain of f function itself, which is less than 0. So which means what is less than 0 in fgx is the gx. Okay, the gx must be less than 0 because of the domain set in the function fx itself. So which means fgx as a whole function will also have a domain of less than 0, the domain in this case is the gx. Right, so let's deal with that first. So let's write down for gx itself, x is more than 4, and for the gx itself is less than 0. So which means the gx, you have a look at gx. Gx has an expression of 8 minus x over 2 is less than 0. So here we are going to solve this inequality, but then solving inequality is an aspect in Mathematics D. You will learn it later in Mathematics D, so I'll just demonstrate on how to do this. Okay, so here you are going to solve this as if you're solving equation, but here you're dealing with inequality. So here move the negative x over 2 to the right hand side, and then solve for x. So x over here is bigger than 16. So let's take note of that first. Alright, so here you see that there are two domains for gx. Okay, so here x is more than 4 and also x is more than 16. So there are sort of like an overlap between them. Overlap of x is more than 4 and x is more than 16. But then one thing in common is that both of them might exist, but the only one that is suitable for this condition is x is more than 16. So therefore the domain of the composite function, which is f gx, is going to be x is a real number. Okay, let's follow up the rule above, and x is more than 16. So that's the domain for the composite function of f gx. Okay, sorry about this one, I forgot to write down the f. Right, let's move on to the range of f gx. Now over here, if you have a look at f gx itself, right, f gx, okay, here you are, we haven't found the expression yet, so let's find out the f gx expression first. So here gx is 8 minus x over 2. Okay, I always start with the right side of the composite function gx, and then fx is x squared plus 4. Alright, so which means f gx composite function is f of the input is the expression 8 minus x over 2. So which means if you look at fx itself, the x is going to be replaced with 8 minus x over 2. So the x squared will become 8 minus x over 2 power 2 plus 4. Right, so this is f gx. Now, going into the range of f gx, okay, we can see that here, this is actually a completed square form of a quadratic function. So this is actually a quadratic function, completed square form. So if you remember the basic from the introduction to function on subtopic number 1, so here basically the composite function is a quadratic with a turning point. So the range for a quadratic function always start with whatever is in the turning point. So in this case, if we expanded this quadratic expression for this one, you will always have a smiling, the positive a x squared. So the form is going to be like this. So we have to identify the minimum point of this quadratic function. Okay, so here this one, as per what I have explained in the previous video, you have to make sure this one is equals to 0. So 8 minus x over 2 equals to 0. So solving this one, okay, will give you x equals to 16, right? X equals to 16. But then the y of the coordinates of the turning point, because this part is a 0, so which means you are left with y equals to 4. So there you are. That's the turning point of the composite function. And then the range, therefore, the range of f(g(x) is going to be, okay, this one, because your domain is including a real number, so the range, the subject of the range, f(g(x), is also consists of real number. And then, because your turning point, the coordinate of the y of the turning point is 4, so that's the basis for the minimum point. So which means at this part, y equals to 4, and it goes above because you are dealing with real number. So which means the range for this composite function, therefore, is f(g(x) is more than 4. So that's the final answer for this example, where you have to find the domain and the range of the composite function. So with that, that concludes the lesson. I hope that everyone is taking note of the subtopic for today. Make sure you fill in all your notes. With that, thank you very much and see you in the next video.